Today the topic of discussion is normalization of data, and in normalization of data we'll study second normal form. So what is a second normal form? Prior to this we have understood what is normalization, we have understood functional dependency, anomalies, all those things, and also understand what is first normal form. Now let's see what second normal form is all about. Fine. So second normal form is based on the concept of full functional dependency. So now my job is to make you understand what actually full functional dependency is all about. So because 2NF is based on full functional dependency, let's start with full functional dependency. So functional dependency x arrow y is a full functional dependency if by removal of any attribute a from x means that dependency does not hold anymore. That is, let me explain. Suppose you have a attribute, you have a functional dependency x to y where x is set of attribute, y is set of attribute. Now suppose by removing any attribute a from x, suppose x was having originally a b c, fine, and I have removed a from x. On removing a, so what left over here? Only b and c. So on removing a from this x, it should not determine y anymore. That is, there is a equal importance of a also in a given x. That is, if you remove a, it cannot define y anymore. That is, importance of a is equal as compared to b and c. Or if you can remove b, or if you remove c, then it cannot derive y anymore. That is what it is showing. If removal of any attribute, I'm saying a, it could be b also, any attribute a from x means that dependency should not hold anymore. That is, for any attribute a, x minus a does not functionally determine I. So in this case, this type of functional dependency, by removing any attribute from x, if the functional dependency is not holding anymore, then this type of dependency is called full functional dependency. That is, it is fully functional dependent on it. It is fully functional dependent on it. You cannot remove. Fine. While what is partial dependency? Same thing. That is, a functional dependency is said to be partial. Suppose this table, this x has a, b and c, and now if I remove a from x, or b from x, or c from x, if the dependency is still holding, then this means that a was not so important. Fine. So this type of dependency is called partial dependency. A functional dependency x to y is a partial dependency if some attribute a can be removed from x and the dependency still hold. See, this is still holding, then that is called partial dependency. Fine, this is called partial dependency. So let's start with a given example. So you have a table. Second normal form is based on the concepts of full functional dependency and states that no non-prime attribute. So what is prime attribute? The attribute which are part of key is called prime attribute. And what are non-prime attribute? Non-prime attribute which are not a part of a key. So if I talk about a table, if you see the table, EID and P number are prime attribute because they are part of key. Fine. While R's name and P name location are what? Are non-prime attribute. So what is definition? 2NF states that no non-prime attribute. That is, if I talk about non-prime attribute, this and this, no non-prime attribute must be partially dependent on key of a table. That is, they should not be partially dependent on key of a table. That is what I am talking about is, let me tell you one thing very clearly. Fine. Okay. So what this means is that, fine, let's see. If I say that, suppose if I say that you have a functional dependency, EID P number determines R's, EID determine E name, P number determine P name and P location. That is, you with employee ID you can determine name. With project number you can determine project name and project location. If you want to determine R's, that is, suppose our employee comes to me and say, sir, I'm looking for my salary. Sir, I'm looking for a salary. So in that case, will I be able to give his salary? I will only be able to give his salary when I have his two information. First, his employee ID, and in which project he is working on. Because if suppose this employee is working on more than 2 projects, more than 3 projects, so, and every project has different R's values. Fine. For a simple project I can give him $5 for an hour, and for a tough project I can give $10 or $15 for an hour. So I'll be needing his employee ID and project number so that I can pay him. Fine. So if I want to determine R, then R is totally depending on this. If you remove any of this, so this will not hold. Fine. Okay. Now if I talk about E name, E name is only depending on EID. Suppose you want to get the name of any employee. Do you require his project number? No. Employee ID is sufficient to give his ename. So what this ID is all about, what this functional, this is partial dependency. While this is full dependency, this is partial, this is full. Why this is partial? Because the complete key is EID and P number. And by removing P number, you can determining a name. That is, P number is not required anymore. And so this is partial. And also this is violating the definition. That is, no non-prime. See, the 2NF states that no non-prime attribute. So, ename is a non-prime attribute. Yes, ename is a non-prime attribute. Must be partially dependent on, and it is partially depending on. It is saying it should not depend on partial. It is depending partially on key of a table. What is key of a table? This is the key of a table. This is a complete key. EID is not a key alone. EID and P number is a key. Ours is following the complete property of 2NF, but this is not following. Again, P name and P location both are non-prime attribute, and these are partially depending on key, because key is made of EID and P number, and they both are depending only on one value of a key. So this is a partial dependency. So this is also violating what? 2NF. So of three functional dependency, these two are violating 2NF. So SSNP number is full functional dependency. That is which I already told you, because if you want to get R's, you need both of the information. You cannot remove any of the information. Fine. While these are partial dependency, and 2NF is based on full functional dependency. Fine. So what you have to do? You have to split this table. You have to decompose. You have to normalize this table to second normal form. So what will be the correct solution? So I have divided table into three parts. Now you can see that the table has this table has this key, and R is depending on both of them. So fine. So it is full functional dependency. This is full functional dependency. Now EID is determining ename. If our table has only one key, there is no case of partial, because it is not dividing it. It cannot be divided. So this is again full functional dependency. If I say P number, P location are depending on P number, so P number is again a single key. So all the three tables, this is again full functional dependency. So all the three tables are in 2NF. So I can say that the table which was previously not in 2NF, now after decomposing, after normalizing, become in 2NF.